Hi, this is Mrs. May. Today we're going to talk about plotting points on a coordinate plane and also talking a little bit about slope. So as we're looking at this basic graph where I've got some points plotted on a coordinate graph, I'd like for you to take a moment to pause the video and write the coordinates of these points that are on this graph. Okay, so if you put -4, 4 for letter A, you are correct. We move to the left 4 and up 4. And one thing, just a reminder, your first coordinate point is your x coordinate, and the second is your y coordinate. This is your x-axis, so you would move left to right first along the x-axis. Um, to whatever number is indicated on your coordinate point, and then you would move either up or down depending on your y coordinate. Letter B is located at -2, -3, moving to the left 2 and then down 3. And the rest of these, if you have C, is at 1, 2, and D at 5, -2. So just a little reminder about x and y, and the x point and coordinate point and the y coordinate point. Looking at also some descriptors, 2, 2 would be located in what would be called the first quadrant. This is quadrant 1, quadrant 2, quadrant 3 and 4. You go counterclockwise around your graph if you can remember that one starts in the upper right and then you go around. So we've got coordinate 2, 2, where your x is equal to 2, your y is equal to 2, and this is in quadrant 1. -3, 1 would be located here in quadrant 2. Your x is equal to -3, y is equal to 1, and that is located in quadrant 2. -1, 4 is right about there, and where x is equal to -1, y is equal to 4, that is also in quadrant 2, and 4, -1, located there, where x is equal to 4, y is equal to -1, and that is in quadrant 4. So just a couple of descriptors and reminders about quadrants and coordinate points. As we're looking at graphing a function, there's a couple of different ways that we can do it. We have a slope intercept form here, y equals mx plus b. So we've got y is equal to -1/2 times x plus 3. Remembering that 3 is where the line will intersect the y-axis. But today we're going to be looking at creating a table and using an equation to draw your line. So we're going to draw a table labeling x and y, where your domain is your x coordinate point. So the domain is -2, -1, 0, 1, and 2. Your range is your y. So if you think of domain as your x, range is your y, and you're going to put these x values into your equation here of y is equal to -1/2 times x plus 3. So when you put in -2 where the x is located here, -1/2 times a -2 is going to be a +1, and 1 plus 3 is 4. -1 times a -1/2 is going to give you a +1/2. And a +1/2 plus 3 is going to be 3 1/2. Anything times 0 is 0, so you got 0 plus 3 is 3. 1 times a -1/2 would be a -1/2 plus 3 is 2 1/2, and I think you can probably see the pattern here. A -1/2 times 2 is -1, and -1 plus 3 is 2. So you can plot your line after you've created this table. I like to use -2, -1, 0, 1, and 2, because the numbers are easy to multiply, and also it gives you both sides of your y-axis. So as we plot these points, we've got -2, 4, which is going to be here. We've got -1, 3 1/2, going to be about there. 0, 3, 1, and 2 1/2. and 2 right there. So when you connect this line, in a perfect world it would be straight. This gives you your line for this equation. And one good thing to just check, you've got a coordinate point right here, and you've got a coordinate point here, and you can always check your slope. You've got a slope of negative 1/2, so you've got a y-intercept of 3, which is right there, where it's intersecting the y-axis, and you've got a negative slope, which tells you the line should be decreasing or going down, and it's going down 1 and over 2, so down 1 over 2, negative 1/2. So that's just a quick way to double check and make sure that your table is correct. Graphing linear equations, is this a solution to the equation? So you're going to have some problems on your assignment where you need to substitute in. Think this is x, this is y, this is x, this is y, and here's the equation. Is it a solution? Well, to figure out if it is a true solution, you need to substitute in your x and y points. So substituting in the 3 where the x is located, substituting the y where the y is located. Does this make a true statement? Is 3 times 3, which is 9, minus 4 equal to 7? No, it is not equal to 7. So this would not be part of your solution set. This would not be, in other words, this would not be a coordinate point on this line. Substituting in x and y for the other coordinate point, when you put 1 in for the x and you put negative 4 in for the y, does that coordinate point work? So we've got 3 times 1, which is 3. Subtracting a negative 4 is the same as adding a positive 4. Yes, that does work. So yes, 1 negative 4 would be on the line represented by 3 times x minus 1 is equal to 7. For your homework assignment, I would like for you to draw a table and make this table and plot some points and connect the points with arrows for the equation negative 2 times x plus y is equal to negative 3. So drawing a table, and if you could use for your domain negative 2, negative 1, 0, 1, and 2, and then plot those points. Also, as a challenge question, I'd like for you to solve and draw lines y equal to 2 and x is equal to negative 1. What do you notice about those lines? And then finally, our last example problem, we have what is called an inequality here. We've got y is equal to negative 3 times x plus 1, and x is greater or equal to 0. So you've got two separate equations here, and I'd like for you to create some tables for both of these. And then when you come in, if you've got the tables, and I will show you how to do the inequality part of it. So if you could just do this side, this equation, and then when you come in, we are going to discuss how you create an inequality. I think that's enough homework for one night, and we will see you tomorrow.